ihasmath, and you're going to learn how to draw a parabola from an equation in factorized form. You've already learned to draw parabolas that are given in vertex form. In this form, you can read off the vertex of a parabola straight away from its equation. Sometimes, however, the equation is given in a different form and it's not always straightforward to do the algebra and change it into vertex form. Have a look at this example. You can see that the equation is not given in vector form because there is no bracket squared here, but instead two different brackets with an x in it. This form of the equation is sometimes called the factorized form, as it has different x's as factors that are multiplied together with nothing else added at the end. It's also sometimes called the intercept form, as the numbers in the brackets allow you to find the x-intercepts. Let's use our understanding of the features of parabolas to see how the equation is linked to the graph. First of all, the numbers in the brackets allow us to find the x-intercepts. When x is equal to 1, the first bracket becomes 0, and 0 times anything is 0. So when x is equal to 1, y is equal to 0. So this represents a point on the x-axis or an x-intercept. The same thing is true for the second bracket at x is equal to -3. Note that the x-intercepts are the opposite parity of the numbers in the brackets. -1 means x is equal to 1 and +3 means x is equal to -3. Secondly, we know that parabolas are symmetrical, so there must be an axis of symmetry halfway between the two x-intercepts. In this case, at x is equal to -1. It's always good to draw this in using a dashed line. Thirdly, we know that on the axis of symmetry there is our very special point, the vertex. Its x-coordinate must be -1, so we can find the y-coordinate by substituting -1 for x in the equation. I strongly recommend using a calculator for this, but don't forget to put in the brackets. The answer is -4 and our vertex has the coordinates -1, -4. This doesn't look so bad. Actually, as the y-coordinate of the vertex is a whole number and there is no vertical stretch, I can now do what I always do, going up one across from the vertex and up by the odd numbers. If this wasn't the case, I would have to take some extra steps at the end. Let's have a look at a different example. Okay, this one is a bit trickier, but we'll get there. Notice the vertical stretch factor of a half. It works the same way as in the vertex form of equation. It's going to be squished. Step 1, draw the x-intercepts at 1 and -2. Step 2, find the line of symmetry halfway between the two. X is equal to -1/2. Step 3, find the vertex by substituting the x value of the line of symmetry. -1.125. Oh dear, this is a bit tricky to draw in, but just do your best. Let's take a quick break here. Going up in a half times the odd numbers from this point is probably not such a great idea. It would be hard and the result is probably imprecise. So here's the new plan. Let's just find some other points on the graph by substituting in the x values. We should probably start with x is equal to 0, as the y-intercept is always an important one. So a half times 2 times -1 is -1. Notice that I just ignored the x in the equation as it is 0. The y-intercept is -1, and because of the symmetry, -1, -1 is also on the graph. Let's try a few more points close to the vertex. Perhaps x is equal to 1 and x is equal to 2. And don't forget to put in the reflections on the line of symmetry. Finally, connect the points. Are you getting the hang of it? I'm going to do one more, but if you think you already know what you're doing, pause the video at any point and try it yourself first. This one looks different. The negative sign at the start tells us that this will be a sad one. But what really confuses some students is the fact that there is an x without a bracket. The equation is still in factorized form, as there are different instances of x multiplied together. The cause for this confusion is the algebraic convention to try and write everything as brief and tidy as possible. The same equation could be written as y is equal to -2 brackets x minus 0 brackets x minus 1, which would make it much easier to recognize the x-intercepts. But people don't write it like that. Just be aware that this is what it actually means. Okay, let's go. Step 1, x-intercepts at 0 and 1. Step 2, axis of symmetry at x is equal to 0.5. Step 3, y-coordinate of the vertex is -2 times a half minus 1 in brackets is equal to a half. Step 4, for other points I'm going to use x is equal to 2 and x is equal to 3 and the reflection. Step 5, connect and celebrate! Some students find this method quite challenging, and I went over the examples fairly quickly. When you take your notes, there is certainly no shame in watching sections of this video again in order to make sure you really got all the steps. Finally, don't forget Plan B. The table function in your calculator will help you to draw any graph at all. So there is really no excuse to skip questions like these. I do think that practicing this method is worth it. It will allow you to find equations of quadratics fairly fast, as you will see in the next video.